Hi, I'm Paul Battaglia, and this is Section 6.1. Students enter Section 6.1 with a wide variety of knowledge in integration skills and techniques, and they now know how to find the area under a curve. And now we're going to take that one step further and look at the area between two curves. And so that's our essential question that we would like students to be able to answer. How do I find the area between two curves? Here's a great way to start off. I like to put two images on the board of two separate functions and ask students just a quick review. How have we found the area under these curves individually? And they know how to do that, and they kind of give that back to me. The next thing I want to do from there is show them a picture of the two curves combined, one on top of the other. And when I do this, I ask the question of students, now how would I find the area between the two curves? And since we've already highlighted the area under each of the curves individually, they usually know that at this point we need to subtract the bottom curve from the top curve. And that leads us into our lesson. So after I've done that, we talk a little bit about the need for finding the top curve. Now you might say, well, if I'm looking at a picture, I already know which curve is on top and which is on the bottom. And that's certainly true. But what about those situations where we're trying to work through a problem that is not calculator active? And some of my students actually struggle to find the quote-unquote top curve. So I'll give them this as a hint. Let's suppose we're dealing with the interval 0 to 10. And I'll say, okay, let's pick a number in that interval. Let's say 5, make it easy. What we want to do is we want to take that number, place it in for x into both functions, and we want to see what the result is. What are we looking for? And hopefully one of your students would say, well, let's see, the one that yields the higher y value would have to be the curve that is in a higher position. So that would have to be the one that comes first in the integrand when we go to set up the proper calculation. So once we've talked about this, we talk a little bit more about how, hey, it's not always going to be that easy. What if the top curve switches in the middle of the interval? So example 4 does a great job of addressing this. Try and have your students look at that if possible. Now, another thing that comes up a lot is maybe that it's not that simple. Maybe it is a little bit more complex. What do I mean by that? Well, sometimes we're given functions that are defined implicitly. Or sometimes visually we can see that there's one function that actually looks like it's on top of itself. So think of like a sideways quadratic function. Well, now it's not really that practical to try and use x's or express our integrand in terms of x. So we have to think about expressing them in terms of y. And example 5 in the text does a great job of illustrating this. But I'd like to highlight exercise 82. It's an AP exercise we've put together, and it gives students two equations. X equals y squared minus 2y. Y equals negative x plus 2. See, now the student has to make a choice. They have to decipher whether or not they should express their integrand in terms of x or y. Now, in this particular example, it would be way more helpful if they just kept it in terms of y, because that first function is a little hard to isolate y. That being said, let's look at a couple things that students are going to encounter when they see this kind of a problem on your assessments or on the AP exam. Now, if it is a calculator active question, certainly we want students to be fluent with their calculator. But we have to look at a couple things. First and foremost, we do not use calculator syntax on assessments or on the exam. We don't say things like, let's try and find the area between these curves, and here's my calculation. The integral of y1 minus y2. We don't say that. But what students can do is they can certainly use functional notation. So maybe they have a very complex or convoluted function, and they really don't want to keep writing it over and over on their page. Well, what they can do, if the problem didn't already state so, is say, let f of x equal this function. Let g of x equal this function. Now, since we've stated that, and we've let the reader know what our intentions are, we can simply say, I'm trying to do the integral of f of x minus g of x. And of course, you want to remember the dx as well. Let's suppose that in finding the points of intersection of these two curves, they got very messy, irrational type of numbers. Well, in these cases, it's best if the student says, let a equal 1.234567, and let b equal 5.12306. In these cases, now that I've defined what my limits are, I don't have to write these messy numbers over and over. I can simply write a to b. And these are nice little tips that will help students be a little bit more efficient as well. Now, if you're looking for a way to make this a little bit more conceptual and address mathematical practice number 4, allowing the student to connect multiple representations,
Exercise number 74
does a really good job of showing the integral as an accumulation function. I hope you found these tips very helpful. I'm sure you'll find much success in section 6.1.